Good morning, sir. This is T. Aftab Hussain. I am pursuing in third year BTech in SRIT College. Today, my topic is about gear dynamic and wear loads. Gear dynamic and wear loads. The introduction to gear dynamic and wear loads. Gear dynamic loads are the forces extracted during gear engagement and motion. Wear loads refers to the forces responsible for material loss and degradation over time. Understanding these loads is essential for designing durable and efficient gear systems. Fundamentals of gear dynamics. Gear dynamics involves analyzing the forces, vibrations, and motion within the gear pairs. Dynamic loads fluctuate during operation due to varying contact conditions. Proper analysis helps predict gear behavior under real-world operating conditions. Types of gear loads. Static loads act when gears are at rest or under steady conditions. Dynamic loads occur during gear engagement, especially at high speeds. Shock loads are sudden, high impact forces caused by observed changes in load or speed. Here are the few figures about gear loads. In figure 1, the driver and driven. The driver is rotating clockwise and the driven is rotating anti-clockwise. In figure 2, here are the driver and driven, which is rotating in opposite direction. In figure 3, which is in rotating in same direction. In figure 4, which is rotating in opposite direction. Factors influencing gear dynamic loads. Gear geometry including tooth size and shape. Impacts load distribution, operating conditions like speed and torque significantly affect dynamic forces. Lubrication quality influences the magnitude and fluctuation of dynamic loads. Gear wear mechanisms. Wear occurs due to frictional contact and material removal over time. Common wear types include pitting, scoring, and adhesive wear. Wear can lead to gear failure if not properly managed or mitigated. We want to see the wear or it will be failure of the gear. We want to check the gear mechanisms, gear wear, where the wear is occurs. Wear load factors. Load magnitude directly influences the rate of gear wear. Contact stress and slip between gear teeth are critical parameters. Here are the environment factors such as contamination and temperature also affect wear. Dynamic load calculation methods. Analytically, methods include Cartesian contact theory and force summation. Numerical approaches like finite element analysis provide detailed insights. Experimental testing helps validate theoretical models and assumptions. Wear load estimation techniques. Wear models often use arcade equation to estimate material loss. Load cycles and contact stresses are integrated to assess wear severity. Accelerated testing can simulate long-term wear in shorter periods. Here are the gears which is rotating. This is the driven and this is the driver. Impact of gear material and lubrication. Material properties influences resistance, to dynamic stresses and wear. Advanced lubricants reduce friction and distribute loads more evenly. Surface treatments like carburizing enhance gear surface hardness and durability. Design strategies to minimize dynamic and wear loads. Optimizing gear geometry ensures better load distribution. Proper lubrication minimizes frictional forces and wear. Incorporating damping elements can reduce vibrations and dynamic forces. Monitoring and maintenance approaches vibration analysis detects early signs of excessive dynamic loads. Regular inspection identifies wear patterns before failure occurs. Condition-based maintenance prolongs gear life and reduces downtime. Case studies and real-world examples. High-speed gearboxes require careful analysis of dynamic loads for reliability. Heavy machinery gears often experience significant wear loads, impacting lifespan. Innovations in materials and lubrication have improved gear performance in various industries. Future trends in gear load management. Integration of sensors and IoT devices enables real-time load monitoring. Advanced materials like composites promise enhanced wear resistance. Computational tools continue to evolve for more accurate dynamic and wear load prediction. In future, it controls the computer where the all sensors will work and sensors will keep for the systems. In this figure, it shows the where the sensors are monitoring in the few things. Summary and key takeaways. Understanding gear dynamic and wear loads is visual for reliable gear design. Multiple factors influence the magnitude and effects of these loads. Proper analysis, materials, and maintenance can significantly extend gear lifespan. Here are the references taken for the video presentation. And thank you for giving this golden opportunity.